All right, before we start to get a solution to a problem, we had to try and address what was causing the problem. Our problem being that these front wheels oftentimes bind up, and when you're trying to turn the stroller, they're misaligned, and that's the problem we're trying to address and fix. The design, as we start talking about the torque involved in this, the center of gravity, we believe, is closer to these back wheels, making them the fulcrum. The beam, you've got handles that extend out. So we measure this, and this torque arm is exactly twice what this torque arm was. So as a result, you're going to have the center of gravity right in here. Now, we have also discussed that as we put a baby in there, unless you put the baby in upside down, you put a baby in here, the feet are going to be the lightest part of that baby. That shifts the center of gravity further towards the back, taking weight. So the proportion of force exerted by this wheel and by this wheel is going to be much different. Now, as a person pushes a stroller, unless they push, if they don't push straight on the handles, if you push straight on the handles, you've added no additional force. Most people are going to push downward on those handles, applying more force to the wheels, and actually, if you're pushing down, you're going to lift up on those front wheels. An analogy we have is, if you've ever been in a tractor, or if you've ridden a four-wheeler and had someone that was heavy on the back of the four-wheeler and going uphill somewhat, you'll have those front wheels lift off the ground. So if you have those front wheels off the ground and you try and turn the tractor or the four-wheeler, nothing happens because there's no friction up front. So we believe part of the problem is, as we push on this and those front wheels lift, when you go to turn, there's no sufficient friction force to cause those wheels to turn. Another problem is, as you turn, if you're pulling on this handle, pushing on this handle, all of a sudden now, instead of both tires being the fulcrum, this left tire, let's say, becomes the fulcrum. If the left tire becomes the fulcrum, we have a triangle. This front wheel is a longer torque arm than this front wheel. As a result, they're not receiving the same amount of friction to equally turn those wheels. One other problem we addressed is, so our solution now is, we believe that if this was 2 feet and this is 1 foot, when we go to turn, these wheels have a 2-foot torque arm from the fulcrum. Our handles have a 1-foot torque arm from the fulcrum. So when we apply a force up top, it's half the force is being applied to those wheels down below, and we have trouble getting it turned. Anyone who's ever used these strollers is continually frustrated with that. Quick solution we thought would be to take the front wheels, put them to the back wheels to the front. Use the front wheels as the fulcrum, and then use these back ones to swivel. We tried it, ran into problems. Because this rod is down in an angle, they will not swivel at all. We already have a prototype set up. Now they don't swivel at all. So we have all 4 wheels that don't swivel. Our next attempt is going to be to try and straighten this, allow these back ones to swivel. It'll make it ride like a tow motor, but we think then you'll have a 3-foot torque arm when you go to try and swivel that, and hopefully the front wheels don't slide. We'll have to see if that's the next problem that we have to address. But at this point in time, that's kind of the physics behind it and where we're headed. The other thing we are going to do, which may be the simplest fix, is we've taken and BJ's drawn up a different length torque arm down in here. So what we're going to do is essentially, you have a pivot point, here's your torque arm. It's about 1 inch long, a little bit less. We're going to double the length of that torque arm, which would require a smaller force of friction to get these wheels to turn. So that's kind of the STEM portion of it, the science and math. That's all.